Hello, I'm Neil Binderman, and today is World Parkinson's Day. And as it happens, I was talking on this very subject earlier this week at a conference titled Neuroscience 2025 in London. And although today is very much about raising awareness of Parkinson's and everything associated with living with that condition, I also feel it's an important day to be able to share aspects of the research that can offer a more positive outlook. And I believe that's what I was touching on when I was talking on the significance of lifestyle and how it can impact progression of a neurological condition. And in terms of impact on progression, that is looking both at terms of progression of the condition and whether we can actually halt the progression of the condition. And I'm going to take you through, in about 15 minutes, I hope, some thinking, which I've basically referred to as neurological thinking or taking a neurological approach. And I've combined that with looking at the use of an artificial intelligence system, which many of us are now exploring, I think, and that is something called ChatGPT. I start with relating the world of Parkinson's to the world of type 2 diabetes, because I believe there are many similarities of what we have learned from diabetes and type 2 and how we may be able to apply that to making progress in the way we approach Parkinson's today and going forward. So I started with asking a few questions and putting them into this ChatGPT system. The first question was this one: does lifestyle cause the progression of type 2 diabetes? And of course, the answer, not surprisingly, is yes. Absolutely, it causes progression of type 2 diabetes. But what about whether it causes type 2 diabetes? And again, of course, today, being 2025, the answer is yes. In most cases, lifestyle plays a major role in causing type 2 diabetes. However, let's just look back 20 plus years. Well, in 2013, this was a statement from Diabetes Care, a major journal, that they expected 50% of individuals to require insulin therapy within 10 years of their diagnosis. And therefore, insulin, as you can see in this chart, was seen as the most credible approach to treatment. And of course, it was also the focus of a lot of type 2 diabetes research. But was that treatment approach actually preventing reversal of insulin resistance? So related to that, can lifestyle reverse type 2 diabetes? And of course, again, we know it can. And it's interesting to see that today, the most credible approach to treating type 2 diabetes is now lifestyle, thanks to innovative doctors like Dr. David Unwin. And that's been done by exploring changes to the likes of diet and also, very significantly, the importance of exercise, taking into consideration the importance of a person's emotions to engage them in these changes. Now, let's just turn to neurological conditions and where we're at today. Can lifestyle changes halt progression of neurological conditions? It's a general question. And the answer is that lifestyle changes can often slow, in some cases stabilize the progression, but rarely halt them completely. And looking at that in a similar way, but can lifestyle cause the progression of a neurological condition? And interestingly, the answer to that one on AI is no. Lifestyle does not cause. And I ask can. It comes back with does not cause. yes, we have to be very careful with how we put in questions to a system like ChatGPT. Be very mindful of what does come back. Now, can lifestyle contribute to the progression of a neurological condition? So a bit of a difference there. Can lifestyle contribute to it? Not necessarily can lifestyle cause the progression, but can it contribute? And yes, it can contribute to the progression of a neurological condition. Now, this is where I go in to look at Parkinson's more specifically. And let's look at what the NHS says about what the cause of Parkinson's is. It's caused by a loss of nerve cells in part of the brain called the substantia nigra. And that leads to a reduction in a chemical called dopamine, which many of us will know. What's interesting, though, is that Parkinson's UK's statement is a bit different. He says we don't yet know exactly why people get Parkinson's, but researchers think it's a combination of age, genetic, environmental factors that cause the dopamine-producing nerve cells to die. Sounds quite similar, in my view, to what it said in type 2 diabetes. So let's compare Parkinson's to diabetes and how it was viewed 20 years ago. Type 1 and type 2 diabetes are characterized by progressive pancreatic beta cell failure, i.e. the loss of insulin-producing cells in the pancreas. Now, that was Diabetes Journal 20 years ago. And to add into that, in 1991, this is when we started to explore the significance of insulin resistance. It was then looked at in terms of its cause of glucose intolerance in type 2. Said then that the resistance cannot be overcome by an increased production of insulin by the beta cell. One person who was leading a lot of the research into insulin resistance was a certain Professor Eli Ferranini, and I had the pleasure and privilege to work and support Professor Eli Ferranini in a significant education project, which led to the publication of this particular paper in 1997. Now, obviously, today we know it's central. Now, what I'm going to do is I'm quickly changing over to explore similarities that there may be between what we've seen with blood glucose and its connection with insulin, and whether there was any significance with that in terms of dopamine. So I asked ChatGPT the question, does a rise in blood glucose, i.e. eating high carb and sweet food, stimulate dopamine? And this came back, which was very encouraging for me, that yes, a rise in blood glucose can lead to increased dopamine release, particularly in the brain's reward circuitry. That is linked to the fact that we know that foods that have got sugar and they're sweet can be addictive. And obviously we know that dopamine is connected very much with addictive behaviors. Now, can dopamine regulate blood glucose levels? It's a bit more tricky with that one, but yes, potentially dopamine can influence the blood glucose levels, so therefore there's some aspect of regulation going on there. So can a rise in dopamine lead to a lowering in blood glucose levels in similar ways we see a rise in insulin, which is far more significantly linked to blood glucose, but can a rise in dopamine actually lower glucose levels? Well, yes, it can contribute to that. It made sense to ask the question, can high blood glucose levels contribute to something called dopamine resistance? So I put that into ChatGPT and the answer came back, yes, the high blood glucose levels can contribute to dopamine resistance, particularly in the brain's reward and motivation system, which makes sense with what we saw earlier. And this happens over time. This particular question was the one that I was really interested to explore. Can impaired dopamine signaling, sometimes called dopamine resistance, contribute to Parkinson's? For me, perhaps one of the most encouraging answers of all, that yes, impaired dopamine signaling is a central feature of Parkinson's disease. Because if insulin resistance can be reversed, can dopamine resistance be reversed? And let's just have a look at this aspect of dopamine resistance in relation to the receptors for dopamine and its connections with emotions. And this slide is to try and give you a bit of a sense of what's going on with food cravings, for example, and the fact that when you become perhaps addicted to high carbs and sweet foods, that it's having a very significant impact on levels of dopamine and the dopamine receptor to be able to give you the feelings that you would get from the release of dopamine. So it's a very, very important aspect of the care of the people with Parkinson's that we need to explore very much their emotional health. Not only that, we need to look much, much further into the current way we're treating Parkinson's. Because is it possible that the treatment for Parkinson's are actually preventing the reversal of dopamine resistance in a very similar way to what we were seeing in type 2 diabetes and insulin? Because, like the approach taken 20, 30 years ago, with insulin being the most credible form of treatment, we're currently doing the same with dopamine being the most credible treatment. And of course, levodopa is the major focus for treatment research. And therefore, our current approach is actually feeding the dopamine imbalance. Because if you're saying to the body that we are giving you the dopamine, the body doesn't need to produce dopamine in a similar way to what was happening in insulin. The insulin injections were being given eventually, and therefore the pancreas didn't think it needed to produce the insulin because those injections were actually still linked to this issue of insulin resistance until new treatments were explored to tackle insulin resistance, then exercise, and that made a massive impact. And what's really interesting is that today we're now all talking about the significance of exercise in Parkinson's. So I'm hoping you're getting the picture of the kind of the logic that I'm applying, because shouldn't it be about enabling the body to rebalance by reducing the demand for dopamine? And I just want to leave you, as we come to the end of this short video, with the possibility that if we were to explore this idea of dopamine fasting in a lot more detail, which is a feature of something that's in this book called The Dopamine Nation by Anna Lemke, we may well have the answer to being able to certainly halt progression and potentially look at ways to reverse that progression in somebody with Parkinson's. So I hope that today, being World Parkinson's Day, that this little video has helped to raise awareness that we have the possibilities of exploring ways to halt the progression and potentially reverse it. Many thanks. Bye-bye.